Hello, I'm Mrs. Edwards, and today we're going to estimate the area underneath a curve using midpoint rectangles, and then we're going to use trapezoids. In both instances, we're going to find the area under f of x, which is x squared, on the interval 0 to 1. So in other words, we're trying to estimate the area of that light blue region there. Now, if you're going to put in 4 rectangles, the first thing we want to do is divide this up into 4 sections. And when you go to divide that up into 4 sections, you can take the amount of space available to you. In this case, it's pretty obvious just looking at it, but otherwise you would take the upper bound minus the lower bound. So 1 minus 0, there is a length of 1 there. And then divided by 4, so when we divide by 4, we get a fourth. And so this first distance is 1/4. Then add a fourth and we get a half. Add a fourth and we get 3/4, and add a fourth and we make it back to 1. All right, we've broken it into 4 equal pieces here, but then it's the midpoint that's going to generate the height of the rectangle. In a previous lesson, we used left-handed rectangles and right-handed rectangles. Okay, but we've got to get the middle of each one of these pieces to substitute in to generate the height. If you want to find the middle of 2 numbers, just remember that you add them together and then divide by 2. Most of you can look at this and say, oh, it's 1/8. But again, if your numbers are a little bit more challenging, remember you can go 0 plus a fourth divided by 2, and that is 1/8. And then the next one, 1/4 plus 1/2 divided by 2 is 3/8. And then to find that value there, 1/2 plus 3/4 divided by 2 is 5/8. And then 3/4 plus 1 divided by 2 is 7/8. These numbers here, 1/8, 3/8, 5/8, and 7/8, those are in the middle, and we use those to generate the heights. So I'm going to take each one of those points that are in the middle, move them up until we hit the curve, and those are going to be the heights of our rectangles. Okay, so now I just want to find the area of those 4 rectangles and add them together, and we will have estimated the area underneath the curve. To find the area of any rectangle, it's just the width multiplied by the height. I'm going to just call the blue rectangle, rectangle 1, the pink one, rectangle 2, rectangle 3 for the green one, and rectangle 4 for the red one. So for rectangle 1, the width of the rectangle, that distance right there, is 1/4. And then the height of the rectangle, we want to plug 1/8 into this function because the y coordinate is the same as the distance off of the x-axis. So I substitute in 1/8. 1/8 times 1/8 is 1/64. Then we're going to take the width multiplied by the height, and we now have the area of the blue rectangle. Okay, then on to the pink rectangle. The width of the pink one is also 1/4. The height of the pink rectangle is 3/8 substituted into the function, so f of 3/8. So we're going to put 3/8 right there, and 3/8 times 3/8 is 9/64. The width of the rectangle times the height of the rectangle is the area of the pink one. Okay, then the green one. The width of the green one is also 1/4. And the height of the green one, we substitute 5/8 into the function. So 5/8 squared, and we get 25/64. Multiply the width times the height, and we have the area of the green one. Lastly, the red one. One more time, the width is still going to be 1/4. And then the height of the red one is 7/8 substituted into the function because the y coordinate on that function is the same as the height. All right, so 7/8 times 7/8 is 49/64. The width times the height is 49 over 256. So if we add all of those areas together, we get 84 over 256. I could simplify that by dividing the numerator and denominator by 4. And so the estimated area underneath the curve on the interval 0 to 1 is 21 over 64. If you would have decided to go with decimals, that would have been fine. You know, you might have said that this is 0.25 and all of the widths are 0.25. You would need to take 0.25 divided by 2, and you would have had 0.125 instead of 1/8, and substituted 0.125 in here, and we would have had a height. The only thing I want to warn you about is if you go with decimals, you're going to be very tempted along the way to round. And if you did this with decimals, you would have gotten 0.328125, and at the very end, you might want to settle for a rounded value. But don't round along the way. Make sure you find the area of each rectangle, the exact area as a decimal, and then add all of those together before you end up rounding in the end. Okay, next we're going to do the same problem, but instead of using midpoint rectangles, we're going to go with trapezoids. Before I continue on to estimating the area under the curve using trapezoids, I'm just going to make a quick homework suggestion to some of you that are having trouble watching a full video and then going to do your homework. So in this particular case, we just went over estimating the area using midpoints. So maybe go to your homework and do just the problems where you have to estimate using the midpoint method of rectangles, and then come back and watch the rest of this video and learn how to do the trapezoids, and then do the homework about the trapezoids. It might just break things up a bit for you, but here we go. On to trapezoids. Quick review of a trapezoid. If you want to find the area of a trapezoid, that is 1/2 times the height times the sum of the bases A and B. The height is the distance between those bases, and our bases in this case are A, this line segment there, and B. Your bases are always the parallel ones, and the height is the distance between those parallel sides. A trapezoid could also look like this, and our height would be there with our bases here and here. Notice this side and this side are parallel, and so those are our bases, and the distance between the bases, that's your height. Even if I rotate the trapezoid and have it look like that, if you go to pick out the bases, this one and this one are parallel to each other, so those are your bases, and then the distance between those two bases, that's your height. All right, so now that we've reviewed trapezoids, the parts of trapezoids, and finding the area of the trapezoids, let's go ahead and put in 4 trapezoids on the interval 0 to 1. So I'm going to put my trapezoids in these 4 spaces, and then at the beginning and the end, you want to move those points up until you hit the curve. Okay, and now we have the spaces created to build our trapezoids, and that is going to look something like that. All right, so notice here this red trapezoid, this side and this side, those are your parallel sides, so those are A and B, and then the distance between those parallel sides, that is the height. So from here to here, that's the height of the trapezoid. In the case of the green one, this side here and this side here, those are your A and B, and then the distance between the parallel ones, that's the height. Same thing with the pink one. And then this blue one, that one's kind of weird. I don't want it to throw you off. It's a triangle, but even when it says use the trapezoidal method, you're going to find the area of that triangle. If you follow the pattern, this length right here and this length or lack thereof, those are the bases, and then the distance between here and here, that's the height. Let's go ahead and put it in action. Finding the area of the trapezoid, this red one, I'm just calling it T4 for trapezoid. We want to go with our formula, 1/2 times the height times a plus b. The distance between the parallel ones is a distance of 0.25, so there's our height. And then to generate the bases a and b, if I substitute 1 into this function, x squared, that distance right there is one of the bases. And then if I substitute 0.75 into the function, that is going to be that distance, and that will be the length of the other base. All right, so if you take 0.75 and square it, and 1 and square it, we're going to get these values. And then I'm going to just follow the order of operations, 0.5625 plus 1, multiplied by 0.25, multiplied by 1/2, and the area of that red trapezoid is that decimal there. I did not round. I don't want to round until the very end, so I kept everything that was on my calculator screen. Okay, next let's do the green one, Trapezoid 3. And for Trapezoid 3, same formula, and the distance right there, the distance between the parallel ones is the height, so that's 0.25. And then the bases A and B, we can get our bases by plugging in 0.5 and 0.75 into our function. Okay, so if I plug in 0.5, that gives me that distance. We'll have 0.5 times 0.5. And then if I plug in 0.75, that's going to give me that distance. So 0.75 times 0.75. And then following the order of operations, I'm going to end up getting this for the area of the green one. We just keep on doing that. Trapezoid 2, that kind of pinkish one there, using the same formula. The distance between the parallel ones is 0.25, so there's my height. And then the length of each one of these parallel ones. If I plug in 0.5 into this function, 0.5 times 0.5 is this 0.25. And then if I plug in 0.25 into my function, 0.25 times 0.25 is 0.0625. Then follow the order of operations, and there is the area of my pink one. And then trapezoid, the blue trapezoid, which is really a triangle. Sure, you could use the area formula for a triangle, and you're going to get the same answer. I'm just going to follow the pattern, though. The distance between the parallel ones, because this doesn't really have any length there, is still going to be 0.25. And then to generate the bases, this length here and this length or lack thereof, when I plug 0.25 into here, 0.25 times 0.25 is 0.0625. And if I substitute 0, 0 squared is 0. Okay, which is why we don't really have a trapezoid, we have a triangle. But we still ultimately have 1/2 base times height, if you want to think about it in terms of area of a triangle. But nonetheless, there is the area of that blue region right there. We add all 4 of those together. And then at the very end, if you would like to round, that's fine. Maybe I go out 3 place values, because on the AP exam, you want to be accurate to 3 place values. So I'll go 7 makes that become a 4, and I'll say the area underneath the curve, x squared, on the interval from 0 to 1 using the trapezoidal method is about 0.344.